Good evening, everybody. Wishing you good night. Today we shall discuss an important subject, which is EEG artifacts. Artifacts are defined as electrical recording of non-cerebral origin. They can be classified into physiological and non-physiological. Examples of physiological artifacts, which are written in black, include ocular, muscle, and cardiac artifacts, while non-physiological include electrode and external device in addition to other artifacts. Starting with the cardiac artifacts. Cardiac artifacts are artifacts that are characterized by being locked to the cardiac contractions. They include electrical and mechanical ones. Electrical can be either EKG electrical artifacts or artifacts related to pacemaker applied, while mechanical artifacts include pulse artifacts and ballistocardiographic artifacts. Starting with the electrical EKG artifacts, we call it EKG to avoid the near pronunciation of the EEG to the ECG. They are usually biphasic, best seen in monopolar montage with air loopule referencing, while in bipolar montage they are more common in the left temporal electrodes due to the cardiac orientation. In this bipolar montage, with exceptional A1 referencing in one channel, we can notice a biphasic regular waves like sharp waves with equidistant intervals. If we have EKG channel, these sharp waves will coincide with those of the EKG exactly. In this monopolar montage with air referencing, similar sharp waves with the same intervals in between. They are found bilaterally but asymmetrically. This is easy because the distance between each successive waves are fixed. But when the heart rhythm is irregular, we may have a problem. An EKG channel must be displayed to show the correlation between these waves and the EKG waves. The pacemaker waves are preceding the QRS complexes at fixed distances. They can also cause EEG artifacts, but at that moment they are very short-lived and polyphasic. Let us see an example. This is an example of pacemaker artifact, short-lived with polyphasic, matching that of the pacemaker on the EKG channel. Then we have mechanical artifacts, starting with the pulse artifact, in which there is displacement of the electrode by the underlying artery. They appear as slow waves simultaneous to the QRS of the EKG. If you move the electrode slightly to the right or to the left, they disappear. This is an example of pulse artifact. They can be found anywhere on the head, more commonly over the temporal and frontal lesions. Here, exceptionally, it's found over the left occipital electrode. Note the relation between the EKG channel and the pulse, sometimes found over the central regions also, like here. To understand the ballistocardiographic artifact, let us see this video.
This movement is too small to be visible with the naked eye, but we can use video amplification to reveal it.
Look on amplification of movement.
Believe it or not, we all move like bobbleheads with different motions at our heart rate, but at a much smaller amplitude than this.
We see in this video very small movement of the head with each pulsation, which can be amplified also by the EEG machine, giving rhythmic artifacts. They are seen in all the channels if the patient is sitting, but mainly over the occipital region if the patient is lying in bed with the head resting on a pillow. If the patient is sitting, it will be like this. Let us see one of the non-physiological artifacts. All these types of artifacts are related to the electrode position and the environment, including pop, electrode contacts, electrode movement, perspiration, bridge artifact, and so on. The first of them is called electrode pop. Pop in English means abrupt explosive sound. To indicate here abrupt change in impedance of this electrode, just elevate the electrode and put some paste or gel below, it will disappear. This is an example of pop electrode artifact over the left front region. This is another example over the left posterior temporal region. Loose electrode may give slow waves limited to that electrode with no field. On repositioning the electrode properly, it will disappear. It usually results from poor contact between the electrode and the scalp due to hair or movement of the head, like the presence of tremors, especially if the electrode is not applied properly. It is evident here over the left mid-temporal region. Here over the right posterior temporal region. In more than one electrode, ionized sodium salt in the sweat can create a field below and around the electrode, giving special type of artifact called perspiration or sweat artifact. These are of low amplitude and low frequency. Can you see them? These are slow components that represent sweat artifact. As the paste is made of material with high conductance to electricity, when there is a bridge of paste between two adjacent electrodes, the potential difference between them will be near zero. So this channel will be nearly isoelectric. When you find bipolar montage with only one channel nearly isoelectric, this is usually a bridge artifact. We have different devices outside the body that can initiate or mediate artifacts. The alternating current of the power, the IV drip machine, telephone rings, ventilators, and pumps, all of them can produce artifacts. Poor earthing of the machine is the most common cause of this type of artifact, which is called 50 Hz AC artifact. You need to know that this type of artifact is not found in machines having their power source from the laptop. They are high frequency 50 Hz monomorphic waves, either present in all the channels, usually with poor earthing, or in certain channels when the impedance of this electrode is disproportionately high. Here it's mainly found over the right temporal line. Here it is 60 Hz because in USA it's usually 60 Hz, not 50 Hz like in our country. Then the IV drip artifact. When the IV drip is near to the electrodes, they may cause characteristic field that give the spike like a picture. These may be misleading, but they are found in most of the channels with equidistance and will disappear on stopping of the solution dropping. Motor or infusion pump or air matrix, the switching magnetic field within the motor machine will produce this type of artifact. It disappears on switching off the machine. Look, each revolving machine gives this type of artifact. Alternating cycles of high frequency artifact is usually electrical motor. Ventilator artifacts may be similar to the ballistocardiographic artifacts. This is to say the movement of the electrode with the movement of the ventilator, giving slow wave-like artifacts. Here it is more evident over the occipital electrodes that rest on the bed, transmitting the movement. Then phone artifacts, as the phone rings, electromagnetic field is generated, giving artifacts simultaneous to the rings, intermittent sinusoidal ones. It's more evident here on the right side channel, as the phone was on the right side of the patient in this case. We have also muscle artifacts. Muscles of mastication, deglutition during chewing give some type of artifacts. Also, muscles involved in forced eye closure during photic stimulation, in addition to any moving muscle related to the scalp, can produce artifacts. EMG artifact is usually of high amplitude and high frequency. Sometimes it is localized, like those found on the right temporalis muscle, or diffuse more than one side. Here on the right side, more evident than the left one. Sometimes widespread, like those seen bilaterally. Note here the central line from the FBZ backward to the OZ, showing minimal muscle artifact, as the central part of the occipitofrontalis muscle is the least mobile one. So this is a characteristic feature of the muscle artifacts of the occipitofrontalis, to be devoid of this type of artifact or minimal artifact at the central line. This is another type of artifact that is found on exposure to sudden light, like those during the photic stimulation. Here, the orbicularis oculi and some other muscles of the forehead reactionally contract, giving bilateral anteriorly placed muscle artifact. They are usually associated with eye flutter-like artifacts locked to the photic stimulation. Tongue movement will produce a field that can alter the background. This occurs during talking, chewing, and deglutition. It is repetitive and of high amplitude. Ocular artifact. This is one of the most important physiological artifacts. It includes many subtypes like blink, eye flutter, lateral gaze artifact, and lateral rectus artifact. The eye pole is like a dipole, with a positive side on the cornea and a negative one on the retina. During eye closure, there is Bell's phenomena, with upward eye rolling, making the positive cornea near the frontopolar electrode. So, frontopolar electrodes will be more positive, giving downward deflection, and vice versa. This is an eye blink artifact. It's evident anteriorly in the frontopolar mainly, and as we look to the channels that occurs posterior to them, these dipping surface positive waves are fading backward and will never appear in the posterior electrodes like the occipital and parietal and posterior temporal one. When the eye movement is repetitively and rapidly closing and opening, this is called eye flutter. Note that the amplitude of the eye flutter is less than that of the eye blinking, but is very frequent, more frequent than the eye blink. Then we move to the lateral movement. This is in which the positive cornea moves towards either F F7 or F8, which are the anterior temporal electrodes. It can be either rapid eye movement like this, or slow eye movement like this. In the stage of drowsiness, the lateral eye movement is so slow and continuous till deeping into stage 1 sleep. When there is a very rapid lateral gaze, the motor unit potential of the lateral rectus may be conveyed to the adjacent anterior temporal electrode, giving short-lived small spike, which is called lateral rectus spike. Look here, it is evident. Thank you very much for your attention. Waiting for your question.